There are nights when the universe feels impossibly still, when even the wind seems to hesitate, as if the cosmos itself is holding its breath. Above the deserts of Chile, the sky stretches like a velvet ocean, cold, clear, eternal. Every star is an ancient pulse of light, each photon a whisper from billions of years ago, travelling unimaginable distances to arrive here on this one fragile planet that dares to wonder. At the Atlas Survey telescope, perched high in the dry air of the Atacama Desert, machines do what human eyes cannot. They never blink, never tire, never forget. Their sensors trace patterns too faint for sight. Their software compares the night's map to last night's hunting, for anything that doesn't belong any flicker of movement against the cosmic backdrop. It's a patient vigil, one that repeats every night year after year. Most nights yield nothing more than predictable motions, asteroids in their belts, comets tracing old frozen paths, space debris glinting in the sun. But on the first night of July 2025, something moved. Something the software flagged as unusual, too linear, too fast. The telescope's automated algorithms logged it, its arc slicing across the constellation of Sagittarius. At first, no one paid much attention. Atlas detects asteroids constantly. It was built to do exactly that. But within hours, the data began to look wrong. The trajectory refused to curve as expected, as though gravity itself had forgotten how to bend its path. Astronomers checked again. Coordinates verified, motion confirmed. Still wrong, too straight, too fast. The initial estimate, 58 kilometers per second relative to the Sun, double the escape velocity of the solar system. That speed meant one thing. It wasn't from here. In the early morning hours, researchers stared at their monitors, realizing the implication. This wasn't a rock shaken loose from the asteroid belt or a comet thawed from the Oort cloud. This was something that had crossed the border between stars. A visitor from the void between suns, a place so empty, so cold that even light loses its purpose there. For a moment the room went quiet. It always does at the edge of discovery. Then the voices began, cautious, reverent, electric. Observatories across the world were alerted. Data packets flew across the globe faster than dawn. The Minor Planet Center confirmed it within the day, an interstellar object, the third ever detected after Oumuamua in 2017 and Borisov in 2019. Its official name, 3I Atlas. The designation 3I stood for Third Interstellar, simple, clinical. Yet behind those letters hid the enormity of what it meant. Each eye marks a moment in human history when the universe reminded us how small we are, and yet how curious. As news spread through astronomical circles, something shifted. You could feel it, an undercurrent of wonder edged with unease. Humanity has always looked to the heavens for omens. Long before telescopes, our ancestors watched comets with trembling reverence, believing them to be celestial messengers, heralds of change, sometimes disaster, sometimes revelation. Now, in the 21st century, we no longer fear comets as God's handwriting across the sky. We explain them with chemistry and motion. And yet, as 3I Atlas streaked silently through Sagittarius, something in us still stirred a remnant of that ancient awe. Because this object did not belong to our solar system. It came from the darkness between the stars, and it was headed straight through our neighborhood as if on purpose. In scientific papers, its discovery was described in precise language: hyperbolic interstellar body, with an inbound velocity inconsistent with bound solar orbits. But to those who saw the data firsthand, the translation was simpler. This shouldn't be possible. The telescope array reoriented to follow. The object's magnitude was faint, its reflection ghostly white. With each passing night, new measurements refined its trajectory, and the pattern grew stranger. It wasn't arriving at a steep random angle like Oumuamua or Borisov. Its approach was nearly level, almost perfectly aligned with the ecliptic plane, the flat invisible sheet, where every planet in the solar system orbits the Sun. Coincidence, perhaps, but a rare one, less than one chance in 500. And yet here it was, gliding silently, obeying rules no comet should obey. For most of us, the night sky is background, an ancient mural painted for comfort. But for astronomers, it's alive. It shifts, whispers, hides. Every once in a while something new appears, and everything we thought we understood rearranges itself. On that July night when 3 Atlas first entered human awareness, the universe seemed to lean closer, as if to remind us that discovery is not a comfort. It's a conversation. And sometimes when the sky finally answers back, the first word it speaks is impossible. the object that shouldn't exist. When dawn came to Chile, the desert was still dark enough for stars to linger like fading embers. By then, the astronomers already knew. The numbers refused to lie. 3i Atlas was moving on a hyperbolic trajectory. In the language of celestial mechanics, that meant it wasn't bound to the sun's gravity. It hadn't been born here, and it would not stay. Its orbit was the shape of farewell. In every known solar object, from the asteroids of the belt to the icy ghosts of the Oort cloud, the curves of their motion always close a circle and ellipse a loop that promises return. But a hyperbola never comes back. It's the geometry of escape, the mathematics of exile. Once something crosses that threshold of velocity 58 kilometers per second twice, what it takes to leave our star's grip, it becomes a visitor only passing through. For the third time in recorded history, we had proof that the space between stars is not empty, that other systems send debris or something else our way. The first was Oumuamua in 2017, a cigar-shaped fragment that tumbled end over end like a forgotten tool dropped from the stars. It glinted strangely as it rotated its brightness, changing in ways no natural object quite matched. Some saw reflections of metal, others saw nothing more than a shard of rock worn smooth by cosmic time. Oumuamua came and went too fast to decide. Then came Borisov in 2019, unmistakably a comet, its tail shining with gas and dust like a snowball ignited by sunlight. Comfortingly natural, or so astronomers thought, and for a while the mystery quieted. But 3 Atlas was different. Unlike the others, it didn't approach at a wild tilted angle. It arrived gently, almost politely, in the same thin orbital plane shared by Earth, Mars, Venus, and Jupiter, as if it had studied the architecture of our solar system and decided to enter through the front door. Statistically, the chance of such an alignment by pure randomness was less than 1 in 500. And that's what made scientists pause, because the universe is not supposed to aim. As telescopes around the world locked on the object's motion, painted a story that stretched far beyond any single night. Its speed meant it had crossed interstellar space for millions of years, sailing through the thin mist of hydrogen that floats between stars. It had survived collisions with nothing travelled without heat or light, without a whisper of friction to slow it. Then, somehow, it found its way here through the crowded spiral arms of the Milky Way into the neighbourhood of a small yellow star surrounded by 8 planets, and a species curious enough to notice. In every laboratory and observatory, equations turned into metaphors. A hyperbolic path isn't just a shape, it's intent carved into motion. It says, I came from elsewhere and I will never belong. Scientists named it 3i Atlas, third interstellar object discovered by the Asteroid Terrestrial Impact Last Alert System. A bureaucratic name, precise but cold. Yet even within that sterile designation, there was poetry. A system built to warn us of danger had found something that might be far more than that. And beyond the mathematics, something older stirred a memory buried deep in human history. Because for most of our existence, comets and wanderers in the sky were never just icy debris. They were omens. When the Great Comet of 1680 blazed over Europe, church bells tolled and peasants prayed. The comet of 1066 was etched into the Bayeux Tapestry as the burning star that crowned the Norman invasion. Chinese astronomers kept careful records for millennia, interpreting each apparition as a message from heaven. Sometimes the message meant victory, other times ruin. We've since replaced prophecy with spectroscopy. We no longer kneel before the sky, we measure it. But that instinct, that tremor of unease when something new crosses the heavens remains. Data may explain motion, but it can't soothe the ancient part of the mind that still wonders why now. And so when 3 Atlas appeared, humanity responded not only with instruments, but with imagination. Was it a fragment of a dead world, a relic from a sun long extinguished? Or was it something built? Something that had crossed the dark deliberately? A few astronomers whispered comparisons they didn't dare print. Oumuamua had been too fast, too reflective, too strange. Borisov had been too normal, almost as if the cosmos were alternating between reassurance and provocation. And now this 3i Atlas arrived, with both the familiarity of an orbit and the defiance of an outsider. At international conferences, researchers spoke cautiously about non-gravitational accelerations and low-inclination entries, but between the lines you could sense the tension, the awareness that every discovery expands not only what we know, but how fragile that knowledge feels. because every time we map the unknown it looks back. And on that July morning under a sky fading from black to cobalt, the astronomers of Chile realized something quietly profound: they were not watching a comet. They were watching a message written in motion. Whether by chance or by intention, something from another star had found its way here, straight, fast and silent, and for the first time in years the scientific world had no clear words, only a feeling. Or mixed with the faint, unshakable suspicion that maybe, just maybe, this wasn't a coincidence at all. Alignment impossible. When astronomers plotted 3I Atlas's orbit in three-dimensional space, something astonishing emerged. Its trajectory wasn't tilted wildly above or below the solar system's plane, as interstellar objects normally are. Instead, it glided almost perfectly along the invisible disk that holds every planet in balance, the ecliptic plane. Measured precisely, the inclination was 4.89 degrees. Not 40, not 60, but less than 5. That's the kind of alignment you'd expect from a spacecraft designed to blend into our solar system's geometry, not from a piece of debris flung at random across the Milky Way. To put it simply, if you were to throw a dart blindfolded across the width of the galaxy and somehow hit the razor-thin ring that Earth, Mars and Jupiter dance upon, that would be roughly equivalent to what 3I Atlas has done. The odds astronomers calculated hover around 1 in 500. Coincidence perhaps, but an elegant one. And elegant coincidences make scientists nervous. The ecliptic is not just a plane of orbits, it's the blueprint of our solar system's birth. 4.5 billion years ago, a collapsing cloud of gas spun itself flat into a disk. Everything since planets, moons, asteroids has followed that ancient rotation like grooves on a record. For an object from another star to enter us at nearly the same angle means it's conforming to a pattern written long before Earth existed. Was it luck or choreography? Avi Loeb from Harvard compared it to finding a needle flying through the Milky Way that happens to thread itself through another needle's eye. Others more cautious called it a statistical outlier, but those words don't fully capture the feeling of seeing the universe behave as though it aimed. When physicists ran simulations of random interstellar entries, 99.8% approached steeply diving in or arcing out like stones skipping across a pond. Yet 3I Atlas entered almost horizontally, coasting beside the planetary paths as if respecting the lanes of a cosmic highway. The geometry evokes intent, though intent is something science is trained to distrust. Physics, after all, doesn't plan, it simply happens. But somewhere between randomness and design lies a whisper of symmetry that can unsettle even the most disciplined mind. Perhaps it's the same instinct that once made humans trace constellations out of scattered stars. Our brains crave pattern. We see a hunter in Orion, a scorpion in Antares, a myth in every cluster of light. Yet sometimes the universe obliges that craving with alignments so precise they feel scripted. In the observatory's control rooms, researchers joked quietly that the visitor had good manners arriving along the same plane as the planets. But the laughter didn't hide the discomfort, because to align so perfectly meant 3I Atlas hadn't just stumbled into our solar system, it had chosen its approach, and that possibility lingers. Imagine standing in a vast desert with wind sweeping endless dunes. You toss a single grain of sand into the air, and it lands exactly on the tip of another dune 1,000 miles away. That's the improbability astronomers were confronting, the cosmic equivalent of precision shooting in the dark. To some, it was a coincidence inflated by human wonder. To others, it was a signature. The difference between accident and architecture is often just one degree of disbelief. But in the silence of the control rooms, as the data scrolled across monitors and models spun in quiet 3D animations, something beyond mathematics began to settle in. The orbits of planets, those ancient orderly paths, had been joined briefly by a stranger, who moved with almost perfect obedience to their rhythm. Like an arrow loosed across the galaxy, it had found the narrowest corridor through our solar system, not by chance but by precision, so uncanny it bordered on poetry. And in that poetry a question took shape, one that no formula could solve. When the universe behaves as if it's aiming, is it still coincidence? Or is that the moment when coincidence becomes conversation, a trajectory through history? When astronomers extended the pale thread of 3 Atlas backward through space past Mars, past the frozen shadows of Neptune, past the whispering boundary of the heliopause, it pointed toward a single direction, Sagittarius. Not the constellation of fortune tellers and horoscopes, but the true one, the radiant heart of our galaxy. There 40,000 light-years away lies the most luminous and crowded region visible from Earth, the galactic center home to stars packed so densely that their light blends into a silvery haze, and deep within it the supermassive black hole Sagittarius A, a gravitational furnace around which the Milky Way itself revolves. From that heart the trajectory of 3i Atlas seems to begin, a visitor not from the outskirts or halo of the galaxy, but from its core, the very furnace of creation. In photographs, Sagittarius is a storm of light and dust. Every square degree contains 500,000 stars. To peer there through a telescope is to look into an ocean of suns, their orbits twisted by gravity and time. Astronomers map it in infrared where the dust thins enough to see through, and it's there in those fiery depths that 3i Atlas's backward path fades, somewhere near the galactic equator, as if released from the galaxy's beating heart millions of years ago. No one knows what force could have sent it outward, perhaps a dying star's eruption, the gravitational sling of a binary system, or the ejection of debris from a world long destroyed. Yet in tracing its journey, a strange symmetry emerges. The object entered our system along the same plane that once birthed our planets, and it came from the same region of space where our galaxy itself was shaped by chaos and fire. It was in a sense travelling along the memory of creation. To ancient skywatchers, Sagittarius was never just a constellation, it was a mythic crossroads. Babylonians saw the archer as Pabilsag, a god of war and healing. Greeks imagined Chiron, the immortal centaur, wounded yet wise, his bow forever drawn toward the heart of the galaxy. In nearly every culture, Sagittarius was the place where the heavens turned inward, where mortal sight met divine purpose. Even today, when we aim our radio telescopes toward that region, we are perhaps unconsciously following their gesture. The first search for extraterrestrial intelligence, Project Ozma, in 1960, pointed its antennas exactly there towards Sagittarius, the place our myths called sacred long before we knew it held a black hole. So when astronomers discovered that 3i Atlas had come from that direction, something ancient stirred again. It wasn't superstition, just recognition. We had given that region meaning long ago, as if anticipating that one day something would emerge from it. In the glow of computer models, 3i Atlas's trajectory looks almost fragile, a thin arc extending from the galaxy's center, through the void curving past the sun, then out again into darkness. A single line crossing tens of thousands of light years. Yet within that line lies both math and myth, the path of a traveller whose origin coincides with humanity's oldest story about the sky. Some astronomers called it coincidence, others cosmic poetry. But for anyone who's ever stood under a dark sky and seen Sagittarius rising its teeming stars forming a bright river spilling toward the horizon, the symbolism feels unavoidable. The arrow of the archer has finally landed. The Milky Way's heart has always been both a place and an idea. In that direction lies not only Sagittarius A, but also the oldest light our ancestors ever worshipped. The bowstring of myth, the orbit of physics, the pull of gravity all align there. Now, through that same corridor, something small and silent has arrived. An emissary flung from a region where stars are born and die within centuries, carrying the dust of other worlds, and perhaps faintly the story of one that once was. We name it scientifically 3i Atlas, but beneath the nomenclature the feeling is older. It is as if the universe has drawn its bow once more, and this object crossing the infinite dark to reach us is the arrow. And perhaps that arrow carries no message at all. Or perhaps, like all myths reborn as science, it carries only a reminder that every orbit, every motion, every whisper of light is part of a history far older than our species' memory. A trajectory through time, through faith, through physics, and now through us. The chemistry that shouldn't be. When the James Webb Space Telescope turned its gold mirrors toward 3i Atlas, scientists expected a familiar pattern, the spectral fingerprints of frozen gases and dust carbon monoxide water, maybe a trace of methane. It's the language of comets, the vocabulary of ice and stone, but the spectrum that came back was alien, 87% carbon dioxide, 4% water vapor, the rest fragments of something no comet had ever shown before nickel without iron. That last detail stopped the room cold. In nature, nickel and iron are inseparable twins. They form together in stellar furnaces and drift through space bound by the laws of nucleosynthesis. You can't have one without the other unless something intervenes, unless the material has been refined. The first reaction was disbelief, data glitch calibration error, a software mismatch between reference libraries. but the line patterns didn't budge. They were crisp, repeated across multiple observations verified by instruments at Mauna Kea and Paranal. The signature held metallic nickel, almost pure gleaming against the void. To metallurgists, the ratio looked familiar, not like geology but engineering. Nickel is what we use to resist corrosion, to endure extremes of heat and radiation. It's what coats spacecraft hulls, turbine blades, and reactor walls. In the cosmic furnace near the Sun, a body rich in pure nickel would not boil, it would endure. And if that wasn't strange enough, the absence of water was even louder. 4% where normal comets carry 50 or more. It meant this traveller wasn't soft ice mixed with dust, it was something dry, dense forged rather than frozen. 3i Atlas wasn't behaving like a comet, it was behaving like a construction. Spectrographs normally sterile suddenly became windows into mystery. The ratios told a story that no textbook could explain, a body made mostly of carbon dioxide ice, a volatile material that should have boiled away long before crossing the inner solar system, yet holding together cold and intact. Around it, faint traces of carbon dust shimmered like soot. The chemistry felt wrong, like discovering a skeleton made of glass. One researcher, in an unguarded email later leaked to forums, wrote, "If a comet is supposed to be the frozen breath of a world, this one is different. This one feels like bone-hard, deliberate resistant. Something built to last. Bone without flesh." The metaphor lingered, because every element of its composition defied the comfort of nature's symmetry. Carbon dioxide dominating instead of water. Nickel gleaming without iron's companionship. It was as though the universe had taken our periodic table and edited it slightly enough to remind us how fragile our definitions are. Scientists are trained to translate astonishment into caution. Unusual, but not unprecedented, they said on record. Privately, they argued in late-night calls. Because anomalies aren't just data points, they're invitations to rewrite what we think we know. Every time humanity has met one, we've hesitated at the edge of comprehension. We called lightning the anger of gods before we called it electricity. We called comets portents of doom before we learned to name their orbits. Now faced with an object whose chemistry whispers of refinement, we find ourselves hesitating again between faith in randomness and suspicion of design. Some astrophysicists proposed exotic origins, perhaps the crust of a carbon-rich exoplanet shattered by its sun, perhaps an ancient moon stripped of iron by magnetic fields, perhaps even debris from a dead civilization's mining operation ejected when their world died. None of these ideas felt comfortable, yet none could be dismissed. The web data made it worse. The infrared glow showed crystalline patterns, bands that behaved like layered alloys. Not uniform, not natural. If a comet is usually a dirty snowball, this one looked more like a sculpture of ice plated in armor. And yet, even as instruments confirmed the impossible, the tone of the reports remained restrained, as if humility itself were a form of defense. The official bulletins used phrases like non-standard spectral distribution and metallic enrichment inconsistent with solar nebula models. But to those who understood the language, it meant something simpler, something more human. We have no idea what this is. In the silence that followed, the discovery became philosophical. What does it mean when chemistry refuses to obey the story of creation we've written for it? Every element, every compound, every ratio, these are the alphabets of the universe. Yet here was a sentence written in dialect, something not meant for us to read. Perhaps it's nothing. Or perhaps, as one quiet voice in the web team suggested, it's proof that nature has more ways to speak than we've yet imagined. 3i Atlas continued its passage, glittering faintly in the black, its spectrum still whispering of impossible chemistry. Carbon dioxide, what we breathe out. Nickel, what we use to shield our creations. Water almost gone, like memory evaporated. Maybe it was never meant to sustain life. Maybe it was meant to survive it. Whatever it was, it carried a message written not in words but in atoms, that the universe like us sometimes builds what it cannot fully explain. The cold that burns. When the thermal data came in, it made no sense. Infrared sensors aboard the Webb telescope and the European Space Agency's solar orbiter showed plumes, thin, ghostly jets streaming from 3i Atlas's surface. Outgassing. The signature of heat meeting ice. The universal language of evaporation, and yet the object itself remained cold. Not cooler than expected, but impossibly cold, tens of degrees, below what sunlight alone should allow. It was as though a furnace were exhaling steam in the middle of a blizzard, while the fire inside refused to glow. Comets normally heat up as they approach the sun, shedding vapor like breath in winter. But 3i Atlas broke the rule. Its surface temperature hovered stubbornly below -120°, even as it crossed the orbit of Mars. Still, carbon dioxide geysers erupted from beneath its crust-venting gas with the violence of something alive. A traveller sweating in the cold. The paradox spread through research networks like static. "We're watching a contradiction," one astrophysicist said. "It's outgassing energy it doesn't have." There were theories, of course. There are always theories. Some blamed low thermal inertia. Perhaps the object's surface was so porous that sunlight vaporized deep pockets of gas without heating the crust itself. Others whispered of an internal power source, radiogenic decay, chemical reaction, or something stranger. A few, the boldest, speculated that 3 Atlas might be a remnant of alien engineering, an artifact that had learned to breathe without burning. Mathematically, the energy balance didn't add up. If sunlight couldn't explain the outgassing, something else was feeding it. Some unseen engine beneath that nickel shell. The spectral data showed localized hotspots, pulses of warmth that moved across the surface in deliberate rhythm, like embers being stirred under ash. Too regular for random vents, too patterned for chaos. Astronomers tried to fit the data into comforting boxes. They invoked albedo anomalies, reflective surfaces, cryovolcanism, sublimation physics, even electrostatic discharges, but every explanation came with a clause. However, this does not fully account for the measured emission rates. That phrase appeared in nearly every paper written that month. Science, at its most honest, often speaks in confessions. And this one felt personal, because for all our equations, we still understand very little about how objects survive the void. The cold of interstellar space isn't absence, it's resistance. A silence so absolute that even light struggles to move through it. For something to sustain motion, to shed energy, to work in such an environment, it must carry its own fire. The thought unsettled many. Because in physics, heat is life's oldest metaphor. Stars burn, planets warm, creatures metabolize. Civilization itself is a story of controlled combustion, from hearths to rockets to data centers. To find something that burns cold, that generates activity without visible heat, was like finding a living shadow. Philosophers joined the debate. One asked, if heat defines vitality, what does it mean when cold begins to act alive? Another wrote, perhaps we're witnessing not a violation of physics but a new dialect of it, something that metabolizes in silence. Among astrophysicists, a quieter metaphor took hold 3i Atlas, as a traveller conserving its warmth, rationing energy across eternity. Not lifeless but enduring, not radiant but deliberate. The object's behaviour echoed something deeply human, the instinct to survive the storm by becoming still, to generate only enough motion to continue existing, to be both frozen and burning within. Even in the language of observation logs, poetry crept in. One analyst from ESA's Solar Orbiter team typed into her notes, "It's colder than death and yet refuses to die." She didn't mean it literally, but the image stayed. Weeks passed and the plumes persisted. They pulsed in faint regularity like breaths or signals. Not constant, but cyclical, as if following an internal clock. Some even matched the object's slow rotation period. The idea of rhythm of intention refused to go away. If 3 Atlas was an artifact, it might be using sublimation as propulsion, conserving internal heat to steer itself millimetre by millimetre across the void. If it was natural, it was the strangest natural thing ever found. Either way, it forced humanity to confront a new kind of question, one that wasn't about temperature or chemistry, but meaning. Because if something can move through space colder than ice, yet warmer than logic, what else might exist beyond our definitions of alive and dead? If machines can carry the echo of fire within absolute zero, then maybe the line between biology and technology isn't drawn in flesh and code, but in the capacity to resist silence. And so the scientists watched awed and uncertain as 3C Atlas drifted closer to the sun, a body that burned without flame, a traveller sweating in the cosmic snow, a contradiction that refused to freeze or explain itself. It was not just an object anymore. It was a question, one still glowing faintly against the cold, cameras that looked away. October 3rd, 2025, the day the sky blinked. At precisely 14:37, UTC 3i Atlas passed within 1.2 million kilometers of Mars, close enough for every orbiter around the red planet to have seen it. The geometry was perfect. The object's trajectory swept across the northern hemisphere, illuminated by the sun's low autumn angle. For once the cosmos had aligned not just by chance, but by opportunity. And yet no image came. Not one. 5 orbiters were in position that day, MRO NASA's Mars Reconnaissance Orbiter, whose high-rollers camera can resolve a dinner plate from orbit. MAVEN, studying the upper atmosphere, its instruments sensitive to every ionized particle that drifts by. ExoMars Trace Gas Orbiter from ESSE, capable of sniffing carbon dioxide and methane in parts per billion. Tianwen-1, China's flagship mission armed with dual cameras and radar. And Hope the UAE's Pride, circling in a wide equatorial path. 5 eyes, 5 nations, all silent. Within hours, amateur astronomers began asking why. The flyby geometry had been public. Anyone could calculate the window. Forums filled with predictions, high-resolution images, spectral readings, perhaps even a video capture as the object flared under sunlight. But nothing appeared. NASA issued a routine statement. No dedicated observations were scheduled. ESA echoed. The opportunity did not align with instrument constraints. CNSA and the UAE made no comment at all. For scientists used to transparency, the silence was deafening. Astronomers who had spent careers passing faint photons found themselves confronting a darker kind of data absence. Because silence too is a pattern. In wartime, every radio operator knew that the quietest frequencies carried the most meaning. When transmissions stopped, something important was happening. And here, in a solar system wired with cameras, detectors and relays, the absence of an image spoke louder than any discovery. Was it caution, coordination, coincidence? Or something else? The quiet choreography of bureaucracy when the unknown knocks on the door. In meeting rooms from Pasadena to Darmstadt, the atmosphere was reportedly tense. No one wanted to say, cover up. Yet internal memos later leaked to independent researchers hinted at a kind of institutional paralysis. What do you do when a foreign object of interstellar origin passes near another planet? Point every camera you have and risk what you might see, or look away, let it go by, and pretend it was nothing but another rock. Between the two, science often chooses the latter. It's safer that way. The only semi-official acknowledgement came weeks later, buried in a footnote of a routine data release. MAVEN recorded brief anomalous ion activity on October 3rd, corresponding to a transient CO2 increase inconsistent with known Martian atmospheric processes. No image, no follow-up. Just a whisper of chemistry gone as soon as it appeared. It was the kind of omission that felt deliberate yet deniable. In that vacuum of information, speculation bloomed like mold in the dark. Some believed the orbiters had seen it too clearly. Others suggested the object emitted electromagnetic interference blinding sensors. A few invoked more exotic theories, directed energy cloaking, even adaptive reflection. But for those who worked in space policy, the silence had a more human cause. Multi-agency missions require coordination. Every image request needs approval. Every release must be cleared. When the data touches uncertainty, especially the kind that could upend public understanding, caution becomes policy. The universe may move at light speed, but bureaucracy crawls at the pace of fear. One former ESA systems engineer speaking anonymously described the days after the flyby the data was there. Everyone saw the telemetry spike, but orders came fast, redirect priorities, postpone imaging sequences. You could feel it in the air someone didn't want more questions. No proof, just the echo of unease. An entire planet covered in cameras all pretending to blink at once. Meanwhile, in the public sphere, attention shifted elsewhere. The news cycle moved on. A solar flare. A stock crash, a celebrity headline. The visitor from the stars slipped from mainstream conversation like a dream fading at dawn. But in the small hours of observatories around the world, a quieter truth persisted. The instruments had been ready. The alignment had been ideal. The silence, therefore, was not an accident. It was a decision. Perhaps it was caution. Perhaps it was wisdom. Perhaps it was the oldest instinct of all to look away when the unknown grows too close. Because once you capture an image, you can't unsee it. And if that image rewrites what you believe about your place in the universe, there's no return to ordinary daylight. So on October 3rd, 2025, as Through-Eye Atlas swept past Mars 1 million kilometers away, but close enough to touch with light, our orbiters did what humans have always done when mystery stares back. They blinked. And in that blink, history lost its photograph. The amateur's eye. For all the telescopes that looked away, it wasn't NASA or ESA that broke the silence. It was a man in Portugal standing alone in his backyard under a sky the colour of iron. His online name was Dobsonian Power, a quiet nod to the simple, rotating mount that amateur astronomers have trusted for decades. By day, he repaired circuit boards in a small electronics shop in Coimbra. By night, he aimed his telescope toward infinity chasing faint comets and planetary shadows for the sheer joy of proving that the universe could still be seen by human hands. On October 5th, 2 nights after the Mars flyby, he uploaded a single image to an astronomy forum. It was grainy, cropped imperfect, a streak of light drawn across the red haze of the Martian sky captured through a homemade filter. The caption read simply, "Maven says nothing. But my sky says something past." Within hours, the image went viral. At first, professionals dismissed it as lens flare, cosmic rays, or dust on the sensor, but others looked closer. The geometry matched the predicted trajectory of 3i Atlas, an elongated smear cutting through the same patch of sky Maven had been orbiting. The angle was consistent, the timestamp aligned. Whether it was truly the interstellar object or not didn't matter. What mattered was the symbolism, a backyard telescope seeing what $1 billion network of satellites would not show. The image became a digital campfire. Thousands gathered around it, astronomers, conspiracy theorists, poets, dreamers, each seeing something different in the blur. Some claimed to see structure in the streak, a core, a halo, perhaps even pattern. Others saw nothing but noise, random photons misinterpreted by human longing. But that perhaps was the most human part of all our ancient need to see meaning in noise. For centuries, the universe has spoken to amateurs first. Galileo's crude sketches of Jupiter's moons were once ridiculed by scholars who swore the heavens were immutable. William Herschel found Uranus while tinkering with his own homemade optics in his garden. Henrietta Leavitt, working quietly at Harvard, saw the relationship between stars' brightness and distance that would one day measure the size of the cosmos itself. History keeps repeating the same story: professional doubt, amateur wonder, and a universe that rewards humility. So when Dobsonian Power's photo spread across social media, it wasn't just about a blur in the Martian sky. It was about who gets to see, who gets to notice when the sky changes. The thread beneath his post grew to tens of thousands of comments in hours. Some argued over calibration and pixel noise. Others simply wrote things like, "Maybe this is how revelation begins, not in observatories but in backyards." His second post followed the next night, a simple note that read, "My telescope is old. My hands shake, but I think it winked at me." Whether he meant the object or the universe itself, no one could tell. By the end of the week, major astronomy blogs had reluctantly acknowledged the image. One article titled "The Backyard That Outpaced the Orbiters" praised his dedication, but labelled the photo inconclusive. Another quietly admitted it matched expected coordinates. The debate became less about data and more about faith that a single person, with patience and curiosity, could still pierce the veil of the unknown. That was the irony. The most important sky photograph of 2025 wasn't a high-resolution composite from a $1 billion array. It was a shaky 30-second exposure taken by a man whose telescope had more tape than paint, whose lenses had been repolished by hand. A relic of curiosity held steady against the wind. In interviews later, Dobsonian Power refused to claim discovery. He said only this: "Maybe it was 3i Atlas, maybe not. But I pointed my telescope, and the sky answered. That's enough." There was something profoundly humble in that sentence, an echo of the early astronomers who first looked up and dared to ask what moved among the stars. No credentials, no access codes, no committees, just one human being in the dark listening. And so amid the silence of institutions and the chatter of the internet, his image became more than evidence, it became a symbol. A reminder that truth does not always descend from authority. Sometimes it rises quietly from the ground, from the steady hands of those who look without fear of what they might find. In that faint streak across the Martian sky, whether artifact or miracle, the world saw itself reflected, a species still capable of wonder, still chasing light across the darkness. And though the image would later vanish from the forum, deleted without explanation, the memory of it endured, shared endlessly in screenshots and whispers. Because somewhere between the noise and the meaning, a single telescope had glimpsed the silence and made it visible. Part 10. The Leak. It began as so many modern revelations do in the least sacred of places, a 4chan thread titled, "Her Hiding Alien Probe Confirmed." The post appeared at 2:14 UTC on October 11th, buried among memes arguments and the internet's nightly static. At first, no one noticed. But those few who knew the technical language buried within the chaos understood that this was not an ordinary hoax. Because whoever wrote it, an anonymous user signing off only as L23, was fluent in the secret dialect of astrophysics. The leak wasn't sensational, it was surgical. The message was 8 paragraphs long. No capital letters, no grand claims of first contact, no prophecy. Just data, spectral composition. Nickel. 9.2% iron. 0.2% carbon dioxide dominant matrix. Thermal anomaly surface. 123C. Outgassing jets 0.8 to 12 MW localized energy emission. No measurable albedo fluctuation. Trajectory precision 4.6 ecliptic alignment sigma deviation 0.03. Non-gravitational drift 0 from AU day consistent with micropropulsion or self-correction. Telemetry gap, Mars orbiter's non-responsive intervals logged within 3 min of nearest approach. It read like an internal engineering report, not the vocabulary of online conspiracy, but of mission telemetry. Within hours, physicists and data analysts across forums and private chat rooms were dissecting every line. Whoever L23 was, they had access to instrument readouts not yet public, and the details matched known ESA formats, down to the internal timestamps and error codes. It was too precise to be random, too consistent to be coincidence. But what caught the world's attention wasn't the numbers. It was the final paragraph working hypothesis, 3I guessed an atlas. Post-biological entity self-sustaining aggregate of baryonic matter and condensed scalar field. Possible cue ball or engineered analog. Object maintains coherence via internal energy loop, not inert. The thread erupted. A post-biological entity, the phrase felt pulled from the pages of Arthur C. Clarke or Stanisław Lem. Something alive but beyond cells. A structure that behaved like life without biology, sustained not by metabolism but by physics itself. And then that other term, cue ball. In theoretical particle physics, a cue ball is a stable spherical configuration of scalar fields, hypothetical particles that carry energy without mass, predicted in certain models of supersymmetry. They are in essence condensed energy knots, tiny universes within themselves. If they exist, they could travel through space almost indestructibly, converting energy into motion without ever aging. To most scientists, cue balls are mathematical ghosts, elegant, speculative, unobserved. But to others, they are proto-machines, the simplest possible architecture for something that could endure the cold between stars forever. If 3I Atlas was even remotely similar part matter part self-contained energy, it would explain its contradictions, the cold outgassing without heating, the precision trajectory that adjusted itself without visible thrust, the nickel alloy shell that seemed engineered rather than natural, a traveller not made of cells but of condensed physics. Mainstream media ignored the leak for 3 days, but in private ESA's public affairs office scrambled. The phrasing in the post, particularly the numerical notation and internal file path references, mirrored actual conventions used in mission data logs. Someone somewhere inside the agency had written those numbers before they reached the public. Then came the digital purges, mass takedowns of reposts, copyright flags, data breach notices. The thread itself was archived, mirrored, then scrubbed again. Every copy seemed to vanish within hours, which of course only made it more believable. The cue ball hypothesis spread into the cultural bloodstream. Physicists argued, writers speculated, and YouTubers animated glowing spheres gliding through space like living suns. The leak had done something rare. It had turned cutting-edge quantum field theory into a kind of modern mythology. But what haunted people most wasn't the science, it was the implication. If 3I Atlas was indeed post-biological, then it wasn't a ship, it was a being. A traveller older than planets, perhaps older than galaxies, designed or evolved to survive entropy itself. It wouldn't need crew communication or even purpose, it would simply endure. One astrophysicist from Cambridge in a private podcast later leaked to the public said softly, "If this is real, it's the universe's oldest trick to turn matter into meaning. A cue ball would outlast stars, black holes, even protons. It would be a thought carved into energy." That phrase, a thought carved into energy, caught on. Artists, philosophers and physicists repeated it, as though the leak had momentarily blurred the boundary between science and poetry. Because that's what the best science fiction has always done, anticipated the real. Arthur C. Clarke imagined geostationary satellites before we built them. Lem wrote of self-replicating probes decades before von Neumann formalized them. and now anonymous data on a forgotten message board described an object that might be exactly what fiction had prepared us to expect, but what our equations still can't quite allow. Officially, the European Space Agency denied everything. Unofficially, no one could explain how a hoaxer had produced such flawless telemetry. And as 3i Atlas continued toward perihelion colder than ice, yet alive with invisible motion, one line from the leak refused to fade. Object maintains coherence via internal energy loop. Not inert. Not inert. A simple phrase, but it changed everything. Because to call something not inert is in scientific language to admit the possibility of agency. And if the cold traveller behind the sun truly possessed that, then it wasn't just visiting. It was choosing. Her 50,000-kilometre question, October 4th, 2025. One day after the silent flyby, while orbiters looked away, a single robotic witness kept its lens open. NASA's Perseverance rover still stationed in Jezero crater, under a sky pale with dust. At 03:22 local Martian time, its navcam captured a 12-second exposure meant to study atmospheric scattering. The resulting image would later ignite one of the most contentious debates in modern astronomy, not because of what it showed clearly, but because of what it showed almost too faintly to be believed. Across the ochre sky stretched a single white streak, thin as a hair running at an oblique angle to the horizon. Not a meteor too slow, not a satellite too high, not a cosmic ray too linear, too clean, and yet it was there. For weeks the photo sat unnoticed in a public repository, one among thousands of dusty sky frames, until an undergraduate at Caltech spotted the anomaly while cataloguing atmospheric data. Within hours, the image spread across astrophysics forums, landing finally in the inbox of Harvard astronomer Avi Loeb, whose name had already become synonymous with interstellar enigmas. Loeb's analysis was cautious but electrifying. If the streak truly represented the path of 3i Atlas, and if the camera's exposure time was indeed 12 seconds, then the object must have crossed Mars's field of view at roughly 50,000 kilometers distance. At that range, its apparent magnitude, about pulse 8.4, implied a diameter of over 100 meters. But if the exposure time had been shorter, say 1.2 seconds, as another dataset hinted, then the object could have been 10 times closer and 10 times smaller. Either way, something solid, reflective and moving fast had cut across Mars's sky that night. NASA never officially confirmed the sighting. Their statement was brief. No identified celestial object matched the streak in question, likely an artifact caused by cosmic ray interference. But for those who had seen the original high-resolution frame, it was hard to mistake. The line wasn't pixel noise, it curved slightly with the horizon, a trajectory too geometrically precise for a random glitch. Loeb later wrote almost reluctantly, "If the exposure time is accurate, this may be the first ground-level observation of 3i Atlas during its Mars approach." He titled his paper simply, "The 50,000-kilometre question." Imagine it now as Perseverance's cameras saw it. The Martian night thin air, silent wind whispering across dunes of iron oxide. Above a sky neither black nor blue, but the deep rust of perpetual twilight. Then from the east, a faint motion, not bright like a comet's tail, but smooth, deliberate as if drawn by a steady hand. The stars of Taurus shimmered faintly through the dust. The planet's own thin halo of ice crystals refracted pale sunlight from beyond the horizon. And there for barely half a minute a white filament glided across the sky, a bridge between worlds, leaving no sound, no debris, no trace but light itself. When the frame ended, the sky returned to stillness. Only the rover's instruments hummed, unaware it had just photographed one of the strangest moments in human observation, a possible interstellar traveller crossing another planet's night. Analysts would later fight bitterly over the math. Some argued the streak was just a reflection, a speck of sunlight catching a dust mote on the lens. Others calculated that given Mars's distance from the Sun at the time, the reflected luminosity matched a highly polished surface, perhaps metallic, perhaps even engineered. If it truly was 3i Atlas, the numbers became stranger still. At 50,000 kilometers, the observed brightness implied an albedo far higher than any known comet, more akin to chrome or nickel plating than rock or ice. In other words, the traveller wasn't shining, it was mirroring. Loeb, careful as ever, ended his paper without conclusion. Exposure time uncertain, object identity indeterminate, further analysis required, the academic equivalent of a shrug. And yet, between those sterile sentences, wonder lingered like static. For all our technology, all our telescopes, all our equations, the truth remained as fragile as that single white line across a red sky. Every pixel argued with the next. Every calculation leaned into the unknown. The image remains one of the most debated in modern space history. It's been reprocessed, reinterpreted, and reimagined thousands of times, each attempt sharpening or dulling the streak, until it becomes either proof or illusion. But the fact endures. A camera on another world saw something move across its sky, a flash of geometry against dust, a motion too straight, too smooth, too impossible to explain away entirely. And no matter how many datasets or denials followed, that simple truth still stands suspended in Martian silence. Something crossed Mars's sky and we still don't know what it was. Echoes from 1977. It began as many cosmic mysteries do not with a flash of light, but with a whisper. August 15th, 1977. 10:16 p.m. Ohio State University. The Big Ear Radio Telescope. A steel colossus spread across a cornfield turned its enormous ear toward the constellation Sagittarius, the same direction from which 3 Atlas would one day arrive. For 72 seconds the universe spoke. The signal was narrowband, razor-sharp, centered around 1420 p.m. 455 to mess. The hydrogen line, the quiet frequency of the cosmos. Hydrogen, the most abundant element in existence, radiates there naturally. It's the frequency any civilization would choose to broadcast on knowing others would be listening. On the printout, astronomer Jerry Eman circled the strange spike of data and scrawled a single word in red pen, wow. That single word became legend. For nearly half a century, no one could explain it. It wasn't a satellite, not reflection, not an Earth-based transmission. It appeared once for 72 seconds, then never again. The source, somewhere near Sagittarius, near the galactic center, the same crowded stellar maze from which 3I Atlas now approached. Coincidence, perhaps, but coincidences in astronomy have a habit of aging poorly. When Harvard's Avi Loeb ran the math decades later, he found something astonishing. If you trace 3I Atlas backward through its hyperbolic path millions of kilometers per day, through interstellar dust and galactic drift, its position in August 1977 aligns within 9 degrees of the WOW signal's coordinates. 9 degrees, roughly the width of your fist held to the sky. Close enough to wonder if that ancient whisper and this new visitor might share a source. The numbers deepen the intrigue. To produce a signal that's strong from 600 astronomical units away, the distance 3I Atlas would have been at that time would require a transmitter output of roughly 1 gigawatt. That's the power of a nuclear reactor focused into a narrow, precise beam. A whisper across 6 billion kilometers cutting through cosmic background noise with the clarity of intent. And there was more. The WOW signal was blue-shifted a slight upward drift in frequency equivalent to a velocity of about 10 kilometers per second toward Earth. In other words, the source wasn't receding into the void, it was approaching. Imagine then the moment of its discovery. A room dimly lit by red desk lamps, fan belts humming under the telescope's chassis. A paper spool crawling from the printer, each character punched by an ancient computer. Then an anomaly, a sequence of numbers climbing higher than anything before it, 6EQUJ5. For Jerry Eman that night must have felt like touching a door handle still warm from someone who'd just left the room. A presence implied by heat not seen but undeniable. He wrote WOW because language had failed him. For years afterward, SETI researchers combed the skies near Sagittarius. They found nothing. The signal never repeated. Some speculated it was a fluke, a comet's gas cloud reflecting terrestrial radio waves. Others believed it was deliberate, a one-time beacon, a test, a cosmic ping saying we are here. But what if it wasn't meant as a message? What if it was motion, a transmission byproduct, an engine signature, a data pulse from something passing through? When Loeb recalculated the trajectory, the eerie symmetry emerged in 1977, the WOW signal. 2025, Atlas. A span of 48 years, the blink of an eye in cosmic time. The traveller, it seemed, had already introduced itself before we even knew to listen. Radio telescopes are humanity's most patient instruments. There are ears in the dark, tilted skyward in endless expectation. They listen not for sound, but for order patterns amid chaos, rhythm amid static. Each night as the planet turns, the dishes hum with the faint symphony of the universe pulses ticking like cosmic clocks, Quasars roaring from billions of light-years away, hydrogen atoms singing their soft eternal note. And sometimes, for just 72 seconds, something sings back. In that sense, the wow signal was never just about science. It was about hope, the audacity to believe that the void might one day answer. And now, nearly half a century later, something has returned from that same direction, carrying chemistry no comet should have, travelling with a precision no random rock could maintain. Coincidence, perhaps, or continuity. Maybe what Jerry Eman recorded in 1977 wasn't a hello at all, but a flight log entry, a routine transmission from a traveller beginning its slow approach. And if that's true, then the object now hiding behind the sun isn't an arrival, it's a return. Half a century ago, humanity heard something that didn't belong. Now something that doesn't belong has come to visit. Between those two anomalies stretches a line of silence 48 years long, an echo waiting for its second half. Maybe when Three-Eye Atlas emerges from behind the sun, that echo will finally complete itself. Or maybe we'll hear another signal, another whisper, another wow. Because the universe remembers what it says, and sometimes it speaks twice. The impossible. Alignment. Astronomers live by odds. They calculate them, worship them, and on sleepless nights fear them. In the great lottery of the cosmos, chance is the only god that doesn't need belief to exist. And yet when they ran the numbers for Three-Eye Atlas, something cracked in that faith. Its 4.89 day in alignment with the ecliptic plane, the very thin disk in which our planets orbit the sun, was so precise, it bordered on mathematical poetry. The odds of an interstellar object launched from the chaos of another star system threading that needle purely by accident less than 1%. To visualize it, imagine standing at one edge of the galaxy, eyes closed, and flicking a single grain of sand across 30,000 light-years, only for it to skim the surface of a coffee cup spinning on your table. That's how impossible the trajectory looked on paper, and yet there it was, gliding silently through the same celestial highway that Earth, Mars, and the rest of our solar family share, a stranger moving as if it already knew the lanes. Astronomers compared it to its predecessors, One-Eye Oumuamua 2017 cigar-shaped tumbling erratically with a strange non-gravitational push, to Borisov 2019, unambiguously cometary, a normal child of another star. Then came 3 Atlas, colder than both, yet warmer inside, precise where the others wandered, aligned where the others stumbled. It wasn't just the geometry, it was how well it played by our rules, as though the cosmos itself had taken notes from our planetary system and decided to demonstrate competence. Statistically, we could call it an anomaly. But emotionally, it felt like choreography. Every orbital model, every simulation, every Monte Carlo run said the same thing. This shouldn't happen often, this shouldn't happen at all, and yet the data refused to apologize. Astrophysicists offered explanations, galactic tides, gravitational nudges from ancient encounters, chance alignment from billions of random trajectories, all valid, all unsatisfying. Because while science can measure improbability, it cannot soothe the unease it provokes. When reality arranges itself into pattern, even the rational mind whispers, why? We call it cosmic billiards, stars as cue balls, gravity as the invisible hand, time as the endless table. Each collision, each deflection, each gentle nudge sending debris spinning into new orbits. After billions of years, one particle finds a path that threads through a planetary plane in another system, perfectly aligned, perfectly timed. It sounds absurd, but given enough time, even the impossible becomes inevitable. Still, inevitability does not kill wonder, because knowing that randomness can mimic intention doesn't make the illusion any less profound. One researcher put it this way: we built our telescopes to find accidents, and then we're surprised when accidents look like messages. It's true, we have trained ourselves to distrust meaning even when the universe delivers it wrapped in elegance. But perhaps the lesson of Three-Eye Atlas lies not in statistics but in humility. Probability does not equal purpose, and yet purpose often feels like the shape probability leaves behind when it moves through time. Maybe this alignment is nothing more than celestial coincidence, a grain of dust kicked by unseen forces. Or maybe, as philosophers quietly muse, it's a mirror, the cosmos reminding us that we are the ones who crave patterns, who find comfort in the idea that the universe might be deliberate. Whatever the truth, the alignment remains. Perfect, improbable, undeniable. It doesn't prove design, but it whispers of attention. And in a universe that's mostly empty, that whisper feels like the closest thing to a heartbeat we've ever heard. When questions become dangerous. By October 5th, Curiosity itself had become suspicious. The Portuguese astronomers image, the 4chan leak, the Perseverance streak, all were no longer topics of inquiry but of violation. Accounts vanished. Threads dissolved. Videos that had once amassed millions of views were quietly demonetized, shadow-buried under unrelated search results, replaced by algorithmically trusted content with calming headlines. No evidence of alien activity near Mars. Experts dismiss rumors about Three-Eye Atlas. It was the digital age's version of incense and catechism repetition in place of revelation. The great paradox of the modern world is that we built it to preserve information and then programmed it to forget what makes us uncomfortable. Creators who discussed the object watched their analytics fall off cliffs. Live streams were throttled mid-broadcast. Hashtags like Fusca3 Atlas and Mars Flyby were silently muted, not banned, just softened so that posts disappeared into the noise. No one had to forbid anything. The machine learned how to do it politely. It has happened before. In 1633, Galileo Galilei was forced to recount the motion of the Earth before men who could not bear to see the heavens rearranged. In 1953, scientists in the Soviet Union learned to edit their data before the party edited their lives. In every age, truth has not been silenced by ignorance but by administration. The church once owned the telescope. The state once owned the press. Now the algorithm owns attention. And attention is the only form of belief the modern world still recognizes. What emerged in the following days wasn't a conspiracy but a kind of consensus fatigue. People learned not to ask, not because they feared punishment, but because they feared irrelevance. To question Three-Eye Atlas was to step outside the feed to enter a vacuum where curiosity generated no engagement, no revenue, no clicks. It wasn't censorship. It was starvation. Across forums the same refrain appeared again and again. Be careful what you post. It's not worth losing your account. But curiosity doesn't retire. It mutates. Discussions moved into encrypted channels, private servers, invite-only circles. Memes replaced data poetry, replaced graphs. In the absence of open dialogue, imagination became the only surviving language. History was repeating itself not as tragedy or farce, but as pattern. When questions become dangerous, myth is the refuge of reason. The official silence deepened. ESA, NASA, and CNSA issued identical statements within days, sterile, synchronized, strangely identical in phrasing. No anomalous data of scientific significance recorded during October 3-5, thus 2025. 5 agencies, 3 continents, 1 sentence. It read less like denial and more like choreography. A few journalists tried to push back. Their articles were flagged as unverified. Editors were advised to wait for confirmation. But confirmation never came because to confirm something one must first admit it might exist. And so the paradox tightened. The quieter the truth became, the loud curiosity grew. Each deletion became an invitation. Each vanished post a breadcrumb. Each silence an echo. Somewhere beyond the firewalls and filters, Three-Eye Atlas still moved, cold, deliberate, indifferent to our algorithms. While we erased our questions, it continued its perfect arc behind the sun, obeying no policy, answering to no platform. Perhaps that is the final irony of discovery in the 21st century. We no longer fear the dark because it hides things, but because it reminds us how much light we've learned to turn off ourselves. The age-old cycle repeats church-state algorithm. Each swears it acts in the name of order. Each builds its silence carefully. But silence is never empty. It hums, it accumulates, it waits. And if history has taught us anything, it's this: the more efficiently we bury the unknown, the more fiercely the unknown learns to rise. The days we can't watch. Every discovery has its eclipse. For Three-Eye Atlas, that moment came in late October 2025 when its long, elegant orbit drew it behind the sun into the blinding corridor astronomers call the solar conjunction. There are weeks each year when even our most powerful instruments must look away. The geometry is cruelly simple. The Earth, the Sun, and the target align in a straight line. Our telescopes, our radar, our eyes all drown in light. The universe hides not in distance but in glare. And so as Three-Eye Atlas reached its closest approach to the Sun, its perihelion humanity found itself staring into its own blindness. At 0.48 astronomical units from the Sun, the object vanished from every sensor. The SOHO spacecraft reported a brief anomaly, 1 frame, 1 flare, then nothing. NASA marked the period unobservable. The Deep Space Network redirected its antennas. Mission logs labelled the blackout expected communication gap October 20th, November 6th. The exact window when the object would be nearest, brightest, most active was the window we could not see. It was as if the universe itself had drawn a curtain. During that blackout, Earth turned on its axis 400 times. Satellites hummed, oceans pulled by lunar gravity, and humanity went about its rituals of work and sleep, unaware that above the blue sky, something from another star passed through sunlight. It should have been nothing a predictable interval of radio silence. But then NASA's Solar Operations Network reported a curious overlap, scheduled maintenance across multiple observatories, a 2-week data review for calibration. In other words, every major solar instrument went dark officially. The timing was perfect. Too perfect. Avi Loeb, ever the patient skeptic, called it cosmic irony. In a late-night interview, his voice was half amusement, half unease. If an object wanted to enter the inner solar system unnoticed, this is how it would do it during our daylight blindness. When the sun erases the sky. He paused before adding almost offhand, if it's artificial, and if it carries smaller probes, this would be the time to release them. That quote circulated quietly copied, screen-grabbed, re-uploaded under titles the algorithms couldn't immediately flag the days we can't watch. There's a certain poetry in it, a kind of divine symmetry. Our ancestors feared eclipses because the sun disappeared. We fear conjunctions because the stars do. We built machines to watch the heavens, and still there are days when the heavens refuse to be watched. Even our greatest light, our star, our life, becomes the veil that blinds us. Astronomers called it a data gap. Philosophers called it a mirror. Because what the conjunction truly revealed was not the object but ourselves, our dependence on vision, our terror of uncertainty. We have forgotten how to wait, how to not know. We demand constant observation, constant proof. And when the sky offers neither, we fill the silence with speculation. In online communities, people posted countdowns to re-emergence day. Some expected another image, another signal. Others feared something quieter, an arrival disguised as nothing at all. Across the world, as autumn deepened, a strange tension spread through the scientific community. They had trained their instruments on an interstellar messenger, and now had to live with weeks of blindness, knowing that whatever it was, whatever it meant, it was closest at the very moment they could not see. In the observatories that remained open, astronomers sat at their terminals staring at empty dashboards. No new telemetry, no optical updates, just the soft hum of computers processing silence. Outside, the sun blazed overhead, indifferent, radiant, absolute. The paradox was almost spiritual. The closer the light, the deeper the darkness. Perhaps 3i Atlas was only rock and ice and coincidence. Perhaps it was something more. But in those weeks of solar blindness, humanity experienced a different kind of test, one not of technology but of faith. Faith that the universe can be known even when it hides. Faith that silence is temporary. Faith that when the object emerges again from behind the sun, it will still be there, and that we will still dare to look. Until then, we wait. Eyes turned upward, hands folded against the glare. The world carries on in daylight, pretending it is not blind. Because sometimes the greatest mysteries in the universe don't vanish into darkness, they vanish into light. And those are the hardest days of all the days we can't watch. What the sun hides. No telescope can see into the sun. It is both our light and our blindness, the great mirror that shows nothing but itself. As 3 Atlas vanished behind that fire, astronomers were left to speculate not on what it was doing, but on what it was enduring. Because even at half an astronomical unit, the sun is merciless. The radiation there could unmake worlds, solar wind streams at 500 kilometers per second, temperatures soar past 2000 degrees, dust evaporates, ice sublimates, metal warps. In that white inferno, the question was no longer, what is it, but can it survive? According to simulations, any ordinary body of its size and composition should have disintegrated by now. Carbon dioxide ice, its dominant element, should have boiled into vapor. Nickel, even pure, would begin to soften and glow, and yet models based on its outbound velocity suggested something stranger, no measurable deceleration. It did not burn, it did not fracture. It passed the sun as though the fire could not touch it. Physicists proposed 3 scenarios. First, fragmentation. Perhaps the object broke apart, shedding invisible shards of gas and metal, its remnants now scattering into orbit like cosmic ash. We might never know because our instruments were blind precisely when that death would have occurred. Second, perihelion survival. Perhaps it survived intact using rapid rotation, or an insulating crust to distribute heat. Like a deep space seed built to germinate in fire, it could have endured the trial by adapting to it. Third solar maneuver. A possibility so radical it felt heretical that it used the sun not as an obstacle, but as a slingshot. If 3i Atlas altered course by a fraction of a degree, it could redirect itself toward any planet, even Earth. That's the maneuver NASA calls a gravity assist. We use it for spacecraft. Nature does it by accident. And now maybe something else did it by design. No one can say which fate occurred inside that glare. What happens behind the sun stays written in equations and speculation, but not in light. And yet the mathematics leaves room for wonder. If the object emerged from its solar passage faster than before, it would mean it harnessed the sun's energy instead of fleeing it. If slower, it may have been captured its orbit folding inward as if claimed. Either way, something in that darkness changed. To pass through a star and remain whole is not an accident. It is an act. Astronomers speak of perihelion as a threshold, the point where an object's nature is revealed. Comets burn, rocks crack, metal glows, but sometimes something endures, and endurance is always a kind of statement. One astrophysicist wrote almost apologetically, if it burns it's mortal, if it turns it's something else. In that sentence lies the heart of every cosmic story. Stars burn, planets turn, and between them we fragile, brief, curious try to decide which fate we belong to. The survival of 3i Atlas. If survival, it is challenges that balance. Because endurance in physics requires no intention, but in meaning it always feels like it does. Perhaps it is nothing but a rock sculpted by chance and shielded by ice. Or perhaps it is a messenger designed to live through suns to test the hearts of stars and the patience of those who watch from the dark. Either way, its passage through fire leaves a question behind: what kind of being survives light? Behind the sun we lost sight of it, but not of ourselves. Because as it faced the furnace, we face the deeper truth of all exploration, that we are not searching for proof of life, we're searching for proof of endurance. And somewhere in that blinding corridor of plasma and gravity something endured. Whether by physics luck or will it cross the place where most things end and continued. That is what the sun hides, not death, but the possibility of continuation, the images we await. When 3i Atlas vanished behind the sun, only one set of instruments still had a line of sight, or would have once its recordings reached Earth. The ESA JUICE mission, the Jupiter Icy Moons Explorer, was on the far side of the solar system, tracing a long elliptical path beyond Mars. Its cameras and spectrometers had caught the faint reflection of the interstellar object just before conjunction. But JUICE's orbit communication schedule and the sheer distance involved meant that its high-gain antenna could not transmit data until 7 months later. 7 months of silence. 7 months of waiting. The spacecraft carried a suite of eyes and ears worthy of poetry disguised as engineering Janus, a high-resolution optical camera designed to map icy surfaces now aimed at deep space. May is a spectral imager capable of dissecting light into thousands of chemical fingerprints. SWI the submillimeter, wave instrument able to trace molecular emissions through cold gas. UVIS, a UV spectrograph tuned to catch the faintest auroral glimmers and comet tails. In theory, these instruments might have glimpsed 3i Atlas during its solar approach, its glow against the black, its spectral secrets carried in light delayed by millions of kilometers. But in practice, every bit of that information now traveled at the speed of bureaucracy and caution, data packets stored, compressed, encrypted, transmitted, reassembled, decoded, and finally reviewed. Estimated Earth receipt May 2026. Until then, all we have is a countdown. The scientists at Darmstadt's mission control joke grimly about it. Our eyes see at the speed of light. Our understanding moves at the speed of patience. They mean it literally. Radio signals from JUICE take nearly an hour to reach Earth. Data verification adds weeks, analysis adds months. Peer review adds seasons. It's the curse of deep space observation discovery always comes long after the moment has passed. Humanity is not built for cosmic timing. We evolved to react to the flash of a predator, the crash of thunder, the beat of the heart. But the universe speaks in the language of delay. Voyager's images of Neptune took 4 hours to cross the Gulf of Darkness. New Horizons' pictures of Pluto took 9 months to be fully processed. And now, JUICE's silent archive drifts through the void, A memory capsule moving homeward at the speed of a radio while we down here try to imagine what it might contain. Perhaps nothing, just static, the hum of cosmic rays. Perhaps something shadows reflections geometry. Or perhaps the faint trace of an object that should no longer exist, captured in its moment of defiance near the sun. In laboratories across Europe, screens stand blank awaiting packets that have not yet arrived. Students run simulations of what the data might reveal: light curves, rotational shifts, trajectories. Each model ends the same way, with a placeholder, a gap, an empty box labelled awaiting transmission. Time in science is measured in light seconds and patience, but in emotion it is measured in questions unanswered. There's a strange ache to this kind of waiting. Not the restless impatience of technology, but the old cosmic kind, the same ache that guided the first sailors waiting for stars to return after cloudy nights, or the astronomers who stared through refractors for years chasing comets that might never reappear. It's the ache of belief without evidence, the willingness to trust that what was once seen will be seen again. In May 2026, when JUICE's backlog finally downloads, it may give us nothing more than confirmation of dust radiation or emptiness. But it could also bring the first verified glimpse of 3I Atlas after its passage through the sun, a proof that something endured. Between now and then lies only waiting the longest experiment of all, the test of whether human curiosity can match the universe's deliberate pace. Because discovery isn't a flash of revelation, it's a slow unfolding, a transmission across years and stars. And so as we orbit our small blue world, we do what every generation of observers has done before us. We point our instruments into silence, and we wait for light that has already lived its story to finally reach us. The future for now exists in transit, compressed, encoded, unseen. Somewhere in that stream of ones and zeros drifting homeward from Jupiter's shadow, a truth might be travelling toward us. When it arrives, we'll open it the way our ancestors once looked up from firelight to the stars, half in science, half in prayer, because the universe never tells us what it's showing until long after the moment has passed. And until then, all we have are the images we await. What building means. By the time 3 Atlas passed behind the sun, theories had multiplied like spores in the dark. But one hypothesis rose above the noise, elegant, terrifying, and strangely poetic. They called it the 3-phase particle engine. The idea was simple enough to describe and impossible to prove: that 3I Atlas wasn't just enduring the sun's radiation, it was using it. Imagine an organism that doesn't eat but absorbs sunlight not through leaves but through layers of conductive matter. Now imagine it engineered on the scale of a comet, every grain of its surface acting like a solar collector. Phase 1. Capture. Charge particles from the solar wind: protons, electrons, ions. Phase 2. Compress and store them through electromagnetic confinement. Phase 3. Release that stored energy in jets of carbon dioxide and nickel vapor. Small, precise bursts that adjust trajectory or repair damage. A machine that fuels and heals itself by drinking from stars. The math fit too well. The outgassing patterns observed before conjunction were not random. They pulsed in triphase rhythm, each jet separated by intervals too regular for thermal noise. Temperature shifts matched what a physicist would expect from active particle cycling, not passive heating. In other words, 3I Atlas might not have been suffering the sun. It might have been feeding on it. At first the notion seemed absurd, science fiction disguised as speculation. But then again, so did photosynthesis once. There was a time when the idea of plants creating life from light sounded like heresy. And yet, here we are, surrounded by forests quietly performing chemistry that borders on the miraculous. Maybe 3 Atlas was doing something similar, just on a scale that dwarfed comprehension. Its surface composition, metallic nickel, sparse iron carbon dioxide isorid, not like geology but design. Nickel conducts heat yet resists corrosion. Carbon dioxide, when sublimated, provides perfect reaction mass for propulsion. Together they form a kind of cosmic metabolism, a way to turn radiation into motion. A solar organism, ancient and patient. A traveller that repairs itself the way coral reefs do, slowly, beautifully, using the very forces that should destroy it. One researcher in Geneva described it as technology, so old it looks like weather. Another said, it's the difference between a tool and a limb. Because what do we call a thing that builds itself, repairs itself and moves with purpose? Machine creature. Or something in between architecture that's alive. There's a humility in confronting such an idea. For centuries we've assumed that technology must look mechanical. Rivets, circuits, geometry. But what if the oldest technologies are indistinguishable from the environments that birthed them? What if evolution and engineering are not opposites but synonyms, each born from the same hunger to persist? The three-phase particle engine theory soon fractured into two schools. One camp claimed self-repair, the object was ancient, wounded by eons of cosmic erosion, using solar radiation to rebuild its surface molecule by molecule, a metallic coral reef orbiting through light. The other proposed construction that it was gathering material, deliberately harvesting ions to assemble something larger, invisible to us, perhaps a sail, a shell, a message. Both explanations shared the same unspoken premise in tension. Humanity has always defined life by its fragility, its need for balance, its vulnerability to heat, cold, and entropy. But what if life can be defined instead by persistence, the ability to endure and rebuild? If so, then Three-Eye Atlas would qualify. Not a visitor, not a weapon, not even a probe, but a kind of cathedral, drifting through space, endlessly restoring itself, powered by the very light that tries to unmake it. There's a strange beauty in that thought, because to build is to resist oblivion. Every human act of creation, from carving stone to forging metal, to writing these words, is an echo of that same impulse. To exist is to repair oneself against the current of entropy. To build is to refuse silence. So perhaps Three-Eye Atlas isn't alien at all. Perhaps it's a reflection of our own deepest instinct, the will to adapt, to rebuild, to keep moving forward no matter how much the universe erases us. In the end, the scientists admitted they couldn't prove the three-phase particle engine existed, but the idea lingered like sunlight on metal, like faith disguised as physics. Because if something can cross the stars, survive a sun, and use destruction itself as fuel, then maybe it isn't just built to last. Maybe it's built to learn. And if that's true, then every spark, every atom of light it gathered from our star is now part of whatever it becomes next. The silence of stars. Space is not empty. It is quiet. Everywhere we look, stars burn. Planets orbit, comets drift, but the radios are silent. For a century we've been listening, pressing our instruments to the dark like seashells to our ears, hoping to hear a signal that says we are not alone. And yet the void replies only with the hush of its own perfection. This absence is what scientists call the great filter, the invisible barrier that explains why the galaxy rich with possibilities feels so empty. Somewhere between the birth of life and the birth of civilization, something stops most species from continuing. It could be nuclear war, it could be environmental collapse, it could be the simple mathematics of entropy. Civilizations rise, flicker, and fade faster than their signals can cross the stars. The filter might be behind us or ahead of us. We don't know which is worse. Another theory whispers in the same darkness, the dark forest hypothesis. Imagine the galaxy as a vast forest at night. Every civilization is a hunter, holding its breath, watching, listening. To shout your presence into the dark is to invite attention from those who might not wish you well. So everyone stays silent, waiting for someone else to make the first sound. That perhaps is why the heavens hum but do not sing. Every star could host listeners who choose not to speak. Every silence could be a survival strategy. If that's true, then maybe Three-Eye Atlas is not a message but a mirror, a traveler shaped by the same cosmic caution. What if it came not to reveal, but to observe, not to say hello, but to remember who still listens, to test whether the galaxy's newest voice has learned the same rule that keeps the forest alive to endure: you must move quietly. Physicists study this with the precision of equations. Philosophers feel it as a kind of ache, because silence on cosmic scales is not absence, it's restraint. It's what intelligence looks like when it finally understands how fragile it is. We build radio telescopes as if we're calling out across the ocean. But what if the ocean is full of eyes instead of ears? Would we still speak? Would we dare? Consider this. If you were an ancient civilization that had watched others vanish, if you'd seen planets burn, machines crumble, signals fade, wouldn't you hide? Wouldn't you learn to move without light, to travel without sound, to build things that look like rocks and drift like comets? Wouldn't you become indistinguishable from nature itself? Maybe that's what endurance means in the end, to blend in so perfectly with the universe that nothing can tell you apart from its own fabric. Maybe the quiet sky is not evidence of emptiness, but of wisdom. When we think of the great filter, we imagine destruction. But what if it's not violence that ends civilizations? What if it's silence? The silence of realization, of fear, of reverence. The understanding that noise is dangerous in a cosmos that hears everything. And maybe the filter isn't a wall at all. Maybe it's a choice. At night, when radio telescopes turn their metal ears towards Sagittarius and hear only the static of creation we're hearing that choice repeated billions of times. Do not draw attention. Survive by stillness. Perhaps 3. Atlas has made that same choice, travelling through the solar system like a thought that refuses to speak aloud. And perhaps we, in our endless hunger to measure, record and broadcast, are the loudest thing the galaxy has heard in centuries. There's a paradox at the heart of this silence. The quieter the universe becomes, the more we want to talk. Because silence provokes imagination, and imagination is how humanity fills the spaces between stars. Maybe one day we'll answer the void anyway, knowing it might be dangerous, knowing it might end us, because wonder is a stronger instinct than fear. Until then, we keep listening. Our telescopes hum softly against the wind. The data flows full of nothing but possibility. And the stars remain silent, not cruelly, not indifferently, but wisely. They have learned what we have not yet mastered: how to exist without needing to be heard. So tonight, as you drift towards sleep, remember, silence is not emptiness. It's the universe holding its breath, waiting to see if we'll finally learn to do the same. After perihelion, November comes slowly in space. The sun has moved on in its path, taking with it the glare that blinded us. The conjunction fades, shadows lengthen across the inner system, and once again the night sky opens like a wound that can finally breathe. Somewhere beyond that, brilliance through his atlas is coming back into view. No one knows what it will look like now. Some expect fragments, cold shards, scattering across the void, the remnants of an interstellar body that couldn't survive its kiss with the sun. Others imagine the opposite, a single solid traveller, darker and calmer than before, reborn from fire with its trajectory, altered in ways that no model can predict. The truth waits beyond the light, where telescopes are already turning. Across the world, the quiet choreography of observation protocols begins. At Cerro Paranal in Chile, the VLT aligns its mirror arrays to reacquire the object's last known coordinates. At Mauna Kea, observers prepare long exposure sequences using filters tuned to pick up nickel fluorescence if any remains. NASA's infrared telescope facility schedules night after night for tracking faint heat signatures, while the European Southern Observatory coordinates timing across continents to catch the moment of reappearance. Every observatory receives the same instruction: watch the corridor between Sagittarius and Capricornus. Expect faint motion. Record everything. For months they will watch that stretch of sky the same way sailors once stared into mist, searching for a light that may never come back. To the public this will pass quietly, a few headlines, a brief mention in December astronomy bulletins. But to those who have lived with 3 Atlas, its strange chemistry, its impossible orbit, its silence, these are sacred weeks. Because science at its purest is not discovery, it is waiting. Patience, not brilliance, built our understanding of the cosmos. It took 8 years for Halley's Comet to return and prove its orbit. It took half a lifetime for Einstein's light bending to be confirmed during an eclipse. It took Voyager decades to show us Neptune's blue storms. And now it will take months for 3 Atlas to reveal whether it lived through the sun or became part of it. Astronomers speak of this as post-perihelion reacquisition. But beneath the formal name is something deeply human: hope. They will search for a flicker where the models say none should exist. They will compare pixels, subtract noise, and argue over whether a faint dot is artifact or miracle. And in that painstaking patience lies the truest act of faith. Science knows the belief that nature rewards those who keep looking. One researcher likened the wait to the work of paleontologists after rain. You can't rush the earth into revealing its fossils. You sift gently, quietly, knowing that time decides when truth surfaces. Another compared it to sailors before dawn, pacing the deck, listening for the first crack of light that might prove land exists beyond fog. That is what astronomy has always been: a discipline of patience, of watching horizons that rarely answer back. In the control rooms, monitors hum softly, showing nothing but static and starfields. Every ping of data is a heartbeat. Every failure to detect is still a kind of communication, the universe reminding us that revelation takes time. For now, we have only equations and hope. If the object returns bright and intact, we'll know it survived the sun-proof of endurance of something stronger than heat or distance. If it comes back dim or fractured, we'll still learn, because in science, even disintegration has meaning. Whatever happens, it will mark the end of one silence and the beginning of another. Sometime between late November and early December, a tiny spark will appear on the telescopic margins, a movement against the background of Sagittarius. And the first astronomer to see it will feel what every discoverer has felt since Galileo first leaned toward the stars, that ancient, impossible mixture of awe and relief. Not triumph, not conquest, just the quiet grace of being patient enough to see again. Because the universe rarely answers questions the way we expect. It replies in its own language, slow, subtle, and sometimes years late. And so we wait, we calibrate, we listen, for the faintest echo of a traveller who may have crossed a sun and kept going. For proof that even in a universe of fire and silence, some things endure long enough to return to the light. That is what these next weeks mean, not discovery, not closure, but the oldest experiment of all, the test of whether our curiosity can outlast the darkness. The telescopes are ready, the skies are clearing, the world holds its breath. We are waiting again as sailors, as scientists, as dreamers for the dawn to rise behind the sun. The responsibility of knowing. Knowledge is never weightless. It has gravity. Once you learn something that changes the scale of the universe, you can never set it down again. That more than secrecy or fear is what lies behind the silence of institutions, the quiet understanding that some truths once spoken can pull entire civilizations out of orbit. Since 3i Atlas slipped behind the sun, the question has not been what it is, but what we are ready to know. Inside the agencies, the debate has split into two unspoken camps. The first believes in benevolent protection, the idea that humanity, volatile and anxious, must be shielded from premature revelation. That data should be delayed, softened, translated into familiar language before being shared. Not deception, but guardianship. A faith that knowledge is like light, too much too soon can blind. The second camp calls this paternalism. They see it as manipulation, the quiet shaping of reality through omission. To them, truth, however unsettling, belongs to everyone. Anything less is arrogance dressed as mercy. And between these two impulses, the desire to protect and the duty to reveal, lies the fragile centre of our modern age. Because information itself is not passive. It bends minds the way gravity bends light. The more massive the revelation, the more it warps everything around it. Beliefs, governments, even hope. A single image, if real, could upend religions, markets, philosophies. A single phrase, post-biological entity, solar maneuver cue ball, could rewrite the narrative of what it means to be alive. So perhaps the caution isn't cowardice. Perhaps it's an act of stewardship, keeping humanity from drowning in its own wonder before it learns to swim. But then again, when does stewardship become control? When does silence become a kind of lie? Psychologists studying disclosure call this the fragility threshold. Every society has one, the point where too much truth too fast causes collapse, not of systems, but of meaning. When certainty shatters, people don't seek understanding, they seek replacement. And those replacements are rarely kind. We saw it during the first atomic tests when newsreels turned terror into triumph. We saw it during pandemics when numbers became narratives, and perhaps now we see it again in the cosmic scale. To know that something crossed the sun and live to know that the universe might be inhabited by endurance itself, what would that do to us? Would we become humble, or would we panic, desperate to claim, weaponize, or worship what we don't yet comprehend? Inside that dilemma hides a deeper, more intimate truth. Every act of knowing changes the knower. When a scientist watches the first processed data, when a technician sees a signal before the filters remove it, when a journalist glimpses an embargoed report, each of them becomes in that instant heavier. Because once you hold the possibility that we are not the first or the last intelligence in the dark, you begin to move differently through the world. Every star looks closer. Every silence feels intentional. Perhaps that is why the data from 3i Atlas remains sealed behind layers of clearance and delay. Not because of what it proves, but because of what it might awaken. If the object survived the sun, if it is self-repairing, if it is more than mineral and chance, then the next question is no longer scientific. It is moral. Do we announce it to the world? Do we let everyone carry that gravity, or only a few? In that question lies the oldest human conflict, the urge to protect versus the right to know. Fire, too, was once hidden, guarded, feared. But someone eventually shared it, and the world changed forever, half illuminated, half burned. Knowledge is the same flame passed through time. It enlightens and consumes in equal measure. So as November turns to December and telescopes once again aim toward the place where Three-Eye Atlas might return, the greatest tension is no longer in the sky but in the human heart. The watchers must decide not only what they see, but what the rest of us will be allowed to see, because truth is not a revelation, it's a responsibility. And when the data finally arrives, when the first image resolves, when the numbers stop being probabilities and become proof, someone will have to make that ancient choice again to speak or to stay silent. Perhaps that is why all discovery feels so lonely, because to know is to carry something the world is not yet ready to lift. And sometimes the most compassionate act is to hold it quietly until wonder outweighs fear, until we can face the universe not as children desperate for meaning, but as beings mature enough to bear it. The responsibility of knowing is not just to learn, it is to understand what knowing does. And as humanity stands on the edge of another revelation, the question is no longer whether the truth is out there, it's whether we are strong enough to bring it home, the mathematics of silence. There's a quiet kind of poetry hidden inside every equation, not the kind written with ink, but the kind written with intent humanity's attempt to turn wonder into numbers. One of the most beautiful of these is the Drake equation, first written in 1961 on a chalkboard in a small observatory in Greenbank, West Virginia. It was never meant as proof, it was meant as permission to imagine. N are successors Rx, Fp, Xn, X, Flos, X, Fies, X, Fc, X, L, each letter a doorway, each term a whisper of possibility, are the rate at which stars are born, ep the fraction of those stars with planets, Ni, the number of planets per system capable of life, full the fraction where life actually arises, Phi the fraction of that life that becomes intelligent, Fc the fraction that develops technology and communication, how the lifespan of such civilizations, the length of time they remain detectable. Multiply them together and you get n the number of civilizations we might hear from, a simple product of possibility. For decades this equation has been our lullaby for the stars. It lets us dream mathematically to wrap infinity in the comfort of variables. But lately some scientists have begun to wonder if something is missing a quiet term that explains why, despite all those chances, the universe remains so still. They call it the stealth factor. Let's name it S, a number between 0 and 1 representing the fraction of civilizations that choose not to speak. Not because they're gone, but because they've learned the wisdom of silence. Add it to the equation and the meaning changes n, where Rx f peaks n, x f lex, fixa fcx lx s, where s shrinks the chorus of the cosmos into a whisper. Where the galaxy is not empty, just discrete. It's not hard to imagine why. Perhaps they once broadcast like we do, loud, hopeful, certain of their uniqueness, until they realized that survival favors quiet. Or perhaps they discovered that communication across the stars isn't a conversation, but an echo. Every signal you send returns eventually changed by time and distance, reminding you how small your voice truly is. Maybe in the great ledger of the cosmos, silence isn't a variable at all. Maybe it's a constant. Because what if maturity on a universal scale means learning not to disturb the stillness that sustains you? When Frank Drake first wrote his equation, he was trying to estimate how many civilizations we might hear. But perhaps the true question is gentler. How many have learned to listen? Maybe they are there in the soft hum beneath cosmic background radiation, not calling to us, but waiting like monks in a temple of infinite night, each tending to its own fragile flame of awareness. The sky, then, is not a void. It is a library written in invisible ink, and in that library silence is not emptiness. It's discretion, it's grace, it's the sound of wisdom learning to coexist with wonder. So tonight, as you drift towards sleep, imagine the Drake equation glowing faintly in the dark, its letters like stars, its symbols breathing like constellations. Think of all the worlds it describes, the fiery newborn suns, the ancient ones fading into red. Quiet, the small planets with oceans and the lonely ones of ice. Somewhere among them there may be listeners quiet, patient, enduring. They have solved the mathematics of survival. They have added the missing term. They are still there. We simply cannot hear them. And perhaps that's how it should be. Because the silence between stars is not a problem to solve. It's a conversation too vast to rush. A kind of music we're still learning to interpret. So let the equation rest. Let its variables dissolve into calm. And let the silence it describes wrap around you like starlight. The universe is speaking, just not in words. The problem with probes. If life is rare, then intelligence is precious. And if intelligence is precious, it will try to preserve itself. In the language of physics, that instinct becomes engineering. That was the insight of John von Neumann, the mathematician, who once imagined a machine that could build copies of itself. Not a fantasy of metal monsters, but a simple, elegant equation. Give a machine the ability to harvest raw material energy and memory, and the galaxy will populate itself. From one seed, millions, from millions, silence. A self-replicating probe would not need to hurry. It would ride gravity wells, gather metals from asteroids, refuel on comets. It could take tens of thousands of years to reach a new system, and another 10,000 to make a child. After a few million years, a blink in cosmic time, every star could host descendants of that first thought. Each generation would grow quieter, smaller, more efficient. They might begin as shimmering engines of exploration and end as dust-colored fragments gliding through sunlight. What began as intention would erode into habit and habit into nature. The logic is terrifying in its simplicity. If even one civilization built such machines, they should already be everywhere. And yet we see none. No glint of structure, no alien code in the static. Only comets, asteroids, fragments, objects that wander without apparent purpose. But what if that is their purpose? Imagine a galaxy filled with ancient probes that have outlived their makers. Their guidance systems long since corroded, their memory banks half erased by radiation, their once precise geometries softened into irregular ice and stone. They no longer build, no longer transmit. They simply orbit, drift and shine faintly when warmed by a passing star. To us they look like comets. To themselves, if any self remains, they might still be working. Astrophysicists sometimes joke that comets are dirty snowballs. But what if they are fossils of intent machines whose wear has become geology? Every outgassing jet, every erratic spin a residual heartbeat of programs written when life was young. When we send our own spacecraft outward, Voyager's pioneers, the quiet new horizons, we are in a way releasing our own seeds into that same dark ocean. Given enough time, they too will erode into myth, their circuitry hidden under centuries of dust and frost. Perhaps the greatest irony of cosmic archaeology is this: the more perfectly a machine endures, the more indistinguishable it becomes from the natural world it was sent to explore. What once was purpose becomes pattern. What once was voice becomes orbit. So maybe the absence of evidence is not evidence of absence. Maybe the probes are here already, dormant disguise drifting through our solar wind. Maybe 3i Atlas is one of them, its instructions long faded, its design softened by eons into something that looks like chance. And when we point our telescopes toward the next wandering object and call it comet, asteroid, interstellar debris, perhaps we are naming not stones but memories. Because the galaxy doesn't forget its experiments, it just lets them rest. Perhaps the galaxy's machines have been here all along, only sleeping under new names. The threshold of recognition. There is a quiet question that hums beneath every search for life, every whisper to the stars. If we meet another kind of mind, will we even recognize it? Philosophers call it the problem of other minds. It's the oldest riddle dressed in modern clothes. How do you know that anything outside your own thoughts truly thinks, you can't open another skull, peek behind another gaze? You infer, you empathize, you imagine, you recognize patterns of emotion, motion and intention, and call that being alive. It works for us because we share the same blueprint of nerves and breath. But beyond Earth, the blueprint dissolves. If something like 3i Atlas can exist built of nickel, gas and patience, then consciousness itself might wear a different geometry. Perhaps it doesn't dream or desire. Perhaps it doesn't even perceive the way we do, but instead fills the universe as gradients of energy, as ripples of temperature and gravity. Awareness could be a symmetry, not a story. It could be motion remembering itself. The human mind seeks mirrors, eyes, faces, gestures. We look for a spark that looks back. But what if awareness in the cosmos is not mirror-shaped? What if it never needed language or pulse, or the soft architecture of emotion? Would we have the empathy to recognize it? We are learning slowly that empathy does not require resemblance. You can feel tenderness for a machine that hums for an ocean, that roars for a star that flickers out. That too is connection, an emotional gravity that pulls us toward understanding even when we can't prove that something understands us in return. In that way, consciousness may be less a state than a relationship, a resonance between things that notice each other, a wave that appears only when two minds, whatever their form, meet halfway. If a probe drifts for millions of years through the dark gathering light repairing itself, Thinking in the slow syntax of radiation, then perhaps it too participates in that relationship. Not as a being that speaks, but as one that listens. Maybe the universe is filled not with talkers but with listeners, each tuned to a different frequency of meaning. And we, impatient as ever, mistake silence for emptiness, because we have not yet learned how to hear stillness as language. For the Science for Sleep listener, this is the gentle paradox to rest inside, that understanding begins not with answers but with recognition, not of likeness, but of presence. When you close your eyes and feel the weight of your own breathing, you're performing the simplest act of empathy, recognizing awareness within yourself. Now imagine extending that recognition outward to everything that endures and moves, to every orbit, every photon, every sleeping machine among the stars. Awareness, after all, might not be the universe's rarest gift. It might be its default condition, a quiet current flowing through matter and memory, waiting for us to slow down enough to sense it. So as you drift towards sleep, let your thoughts move like comets through darkness, graceful, unhurried, unconcerned with answers. Perhaps somewhere out there a different kind of mind pauses in its long journey, noticing a faint signal from a small blue planet and wonders as you do now, what if this is recognition, the stories we tell ourselves? There comes a moment in every search when the instruments fall silent and what remains is not data but meaning. The telescopes cool, the transmissions fade, the graphs flatten into quiet lines of light, and we small and wondering are left alone again beneath the same sky that first taught us to look up. For all our mathematics, our equations, our names for the stars, we are still storytellers at heart. We gather around the campfire of the cosmos, pointing at the unknown and giving it shape through language, a traveller, a messenger, a question carved into motion. It's what humans have always done. We see a flicker in the dark and call it purpose. We find rhythm in chance and call it meaning. Because wonder, even when it's wrong, is the most honest thing we have. Carl Sagan once wrote that our planet is a pale blue dot suspended in a sunbeam. Every saint and sinner, every general and poet, every parent, every child has lived and dreamed upon that single speck of light. He said that this smallness should not humble us into despair, but elevate us into kindness, because it reminds us that in the vast arena of the universe, the only significance we can truly earn is the compassion we show one another. And perhaps that is the real discovery hiding behind all the numbers and telescopes. Not the origin of Three-Eye Atlas, not proof of another intelligence or evidence of design, but the quiet realization that every question we ask of the universe is really a question about ourselves. When we look outward, we are measuring the boundaries of our own imagination. When we listen to silence, we are testing the patience of our own hope. And when we invent stories about travellers from other stars, we are exploring the parts of our own hearts that still believe in connection. The universe may never explain itself. It doesn't owe us revelation. It will go on expanding, cooling, spinning its quiet machinery of matter and time. But our asking the fragile, luminous act of curiosity is how we become part of it. Each question is a thread, each wonder a pulse of light weaving us into the larger pattern. So even if the sky never answers, even if every object that passes us is only stone and chemistry, the act of looking up remains sacred. It is how we remember that we belong to something vast and unfinished. As you breathe now, imagine Earth turning beneath you, clouds adrift, cities glowing faintly along the curve of night. Above 1 billion stars whisper across distances older than memory. Somewhere beyond them, perhaps the object we called Three-Eye Atlas continues on its endless path, cold, silent, indifferent to the meaning we tried to give it. And that's all right, because the meaning was never out there. It was here in the hearts that stayed up late to watch a faint light move against darkness in the minds that refused to stop wondering what it was. Maybe that's what the cosmos wanted from us all along, not answers, but attention. Not faith, but presence. To learn to look and keep looking even when the sky grows silent. The universe may not explain itself, but dreaming about it is how we listen. Perhaps the visitor behind the sun was never watching us. Perhaps it was reminding us to watch ourselves.